Good morning, afternoon, or evening. In this video, this physicist will briefly explain their Physics 1 roller coaster assignment, starting with the key concept of the law of conservation of energy, which states that energy is neither created nor destroyed, but instead it transforms from one form to another. Therefore, calculation-wise, if all forms of energy were taken into account, the total energy of a particular isolated system will always remain constant. The project focus question is, how does the law of conservation of energy explain the motion of a roller coaster, and what factors in roller coaster designs affect energy transformation and efficiency? So, since energy transforms into different forms, in a roller coaster, this means that energy moves between potential energy and kinetic energy, which, in other terms, the transformation of stored energy turns into kinetic energy in changes in velocity, which make up the motion of a marble traveling a roller coaster. The factors that affect energy transformation and efficiency are the initial drop at the start of the roller coaster, namely its height, because the taller it is, the more energy it has stored, which means greater mechanical energy, which means that it needs to be tall enough to have enough mechanical energy to get to the end of the ride, as well as the friction between the roller coaster track and the marble, because too much friction causes it to expend energy, which would cause it to lose velocity, especially if the paper overlaps in a way that is not conducive to the marble, as well as bad overall design of the track, because if there are too much abrupt changes, it would cause too much loss of velocity. Based on the roller coaster project, it demonstrates the principles of energy conservation and transformations relatively well, because it starts with a high potential energy due to the great drop from the first hill, which allows it to pass the loop well, which technically causes loss in velocity, but it makes the practical roller coaster more fun and exciting in application. The energy transformation demonstrated is mechanical energy from the marble converting into sound, vibration, and heat, as well as the transformation of stored potential energy into kinetic energy. The specific changes that could have been made to improve the roller coaster's efficiency is making the roller coaster track neater, which would allow for greater gain in velocity, strengthening the supports to stabilize the model as a whole, as well as making the initial drop taller, which would allow for maximized potential energy. The roller coaster demonstrated the law of conservation of energy because it demonstrated that energy transformed, namely in potential energy turning into kinetic energy via the marble's motion, and mechanical energy becoming sound, vibration, and heat, which, when accumulated and added together at the end, would total to the initial energy at the start. The strengths of this design was the high initial drop from the first hill allowing great gain in velocity, and the loop tilting down causes the marble to accelerate. But the weaknesses is the first curve from the hill towards the loop causes a great loss of velocity due to the inefficiency of design, as well as the instability caused by lack of supports causing energy to be lost, transforming into vibration, which lacks energy efficiency. The quantitative estimate of energy loss at the end of the round, found by subtracting the mechanical energy at the start with the mechanical energy at the end, is 2.4 times 10 negative 2 joules. The specific actionable improvements that the community could have made to the roller coaster design that this physicist recommends is to reduce the length of the initial curve after the first drop of the hill, which would reduce energy loss, increase the height of the first drop to optimize work and power output because it increases the potential energy, as well as increase and strengthening supports by adding diagonal and paper taping the existing supports because it improves energy efficiency by preventing conversion of mechanical energy into vibrational energy. Aside from that, the contributions that this physicist made to the project were the ideation and creation of a model, data measurements and observations, as well as calculations, and in terms of meta-level reflection, setting up planning by planning to have all the parts work properly, thoughtful learning by regularly asking for feedback from peers and revising accordingly, as well as evaluating the strengths and areas of improvement for the roller coaster design. That is it for this physicist explanation. Thank you for listening.